solar energy costs have dropped by nearly 90% in the last 10 years. According to the Solar Energy Industries Association, the average-sized residential system cost has dropped from a price of $40,000 in 2010 to roughly $20,000 today. Despite the impressive progress, the high cost of installation remains the main reason for discouraging many homeowners from switching to solar energy. Fortunately, there are numerous government incentives available that can significantly reduce the cost of going solar and help homeowners reduce their carbon footprint while saving money on their energy bills. In this video, we will focus on the various government incentives and basic product knowledge to help consumers make an informed decision about whether or not to switch to solar energy. The federal government, as well as many state and local governments, offer various incentives to homeowners who choose to install solar panels. Some states have also implemented net metering laws, which allow homeowners to sell any excess energy they generate back to the grid. This can provide an additional source of income for homeowners. In addition, special rates and discounts from utility companies can reduce the cost of installation even further. In addition to installing solar panels on their property, consumers also have other means of benefiting from solar power through their utility companies or community-based projects. We will visit these options shortly. Residential-scale solar projects are typically small due to limited available space for installation. These projects are about 5 kilowatts or around 20 panels installed on rooftops of homes or open land. Fortunately, because of the improved panel efficiency, we can generate twice as much power from the same space today than we did 2 decades ago. Efficiency rate is the rate at which solar cells convert sunlight into electricity. Today, the average residential panel efficiency is about 23% compared to only 13% in the early 2000s. This significant jump in efficiency has resulted in the power rating of a standard-size panel increasing from 200 watts to over 450 watts. The improved efficiency has led to the rapid growth in the residential solar power capacity. In 2023 alone, the residential sector set an annual record at 6.8 gigawatts, an increase of 13% compared to the previous year. Understanding the basics of solar panels and the required additional components is crucial to evaluating the expected project cost and the available financial incentives. Solar panels are made of multiple parts, of which solar cells are the most critical component. Over 90% of the cells in the market today are made of silicon, which is one of the most abundant non-metal elements on Earth. Silicon has the second highest melting and boiling points of the non-metals. Therefore, silicon-based cells can withstand harsh elements, whether it be from the sun's heat or freezing temperatures. More importantly, exposing silicon to the sun breaks its molecular bond, leading to loosened electrons, which are the source of electricity. The efficiency, power rating, and cost of solar panels depend on the purity of the silicon used in manufacturing. Solar cells manufactured from a single silicon crystal are known as monocrystalline cells, and they have the highest efficiency and power capacity. These cells are distinguished from others by their dark color, which is the appearance of pure silicon crystals when exposed to sunlight. Any fragmented silicon pieces resulting from the manufacturing process are melted together in a mold and cut into wafers to produce lower efficiency solar cells known as polycrystalline solar cells. These cells appear bluish due to how light reflects off the cell's silicon fragments. Many of these are packed in standardized 60, 72, and 96 cell variances and are protected by metal frames and glass casing units to make solar panels. Finally, wiring cables are added to the panels to transfer the electric current from the cells to the devices to be powered. In addition to the traditional solar panels, there are bifacial and thin-film solar panels available in the market. Bifacial panels capture sunlight from both the front and back of the panel, leading to 10% to 30% more electricity production. These panels have to be installed at a tilt to allow for light to reflect on both sides of the panel. Thin-film solar cells, on the other hand, are flexible and lightweight and mainly used for portable applications, such as backpacks and RVs. Thin-film applications for residential installations are fairly new but growing fast. In addition to solar panels, generating solar power requires other hardware, including inverters, batteries, and charge controllers. Inverters convert the direct current generated by the panels into the alternating current used for most of our electrical devices. They are also used for monitoring and optimizing the solar power system. Some of the different types of inverters in the market include microinverters, macro or string inverters, and power optimizer inverters. Microinverters are attached to each panel for DC to AC conversion. Therefore, a failure in a single panel does not impact the other panels. This makes them more efficient and more expensive. Macroinverters, or string inverters on the other hand, are used in a centralized way where each panel is wired into a string and connected to a single central inverter. In this system, failure in one panel can impact the performance of the overall array of panels. Inverters that combine the advantages of both the micro and macro technologies are power optimizer inverters. Like microinverters, they are placed on each panel to improve efficiency. However, like macroinverters, the DC to AC conversion is done at a centralized location, reducing maintenance and repair costs. Since solar panels can only produce power when the sun is shining, storing excess solar power is increasingly becoming important. Batteries provide storage and therefore provide energy reliability. Finally, charge controllers are the on and off switches for a battery system, allowing power to pass when the battery needs charging and cutting it off when the battery is fully charged. Depending on the size, residential scale projects can be installed as off-grid, on-grid, or hybrid systems. Off-grid is a standalone system where the facility generates enough power for itself and is not connected to the utility company's grid. On-grid system, on the other hand, is tied to the utility company's grid, therefore requires no battery storage. Hybrid grid incorporates both systems. It has a battery storage system and is also connected to the utility company's grid. Besides installing panels on their property, consumers can benefit from solar energy by other means. The U.S. solar power capacity is spread across various scales including utility, commercial, community, and residential sectors. Utility-scale projects are large installations that provide solar power to utilities. Consumers can purchase solar power from their utility companies. Consumers can also benefit from community-scale projects which are built in a central location. These projects allow residential consumers to subscribe and receive solar power without installing panels on their property. Finally, commercial-scale installations provide businesses with on-site solar power. Major U.S. corporations have installed 19 gigawatts of solar capacity across nearly 500,000 different facilities across the country. In the age of tech giants and data centers, the more these businesses become self-sufficient, the less they compete with the average consumer. As of 2023, the U.S. had over 125 gigawatts of installed solar power capacity, enough to power 30 million homes. Today, solar power accounts for 3.4% of total U.S. electricity and has ranked either first or second in capacity added to the entire U.S. electric grid system every year since 2013. Additionally, the cost of electricity from solar power has been reduced by nearly 90%, from 45 cents per kilowatt-hour to 5 cents per kilowatt-hour in just a decade. Despite this astonishing growth, residential-scale solar projects remain low. With the passing of the Inflation Reduction Act in 2023, a reasonable number of financial incentives aim to re-energize the sector. Thanks for watching. If you're interested in learning more about renewable energy solutions, be sure to check out our other videos.